Hey guys, it's Mr. Lee, and I just wanted to debrief the Chapter 6 quiz because everyone's taken it at this point. So I'm going to go through the FRQs for the multiple choice questions. You can go back through your own and see the results, which ones you got wrong, and what the correct answers were. But for the FRQs, I want to talk about the question, the setup, the solution process, and the final answer. So in question one, you're asked to do a simulation. So this is a review question, and it gives you that 10% of Southwest customers miss their plane flights on any given day. Okay. And so when you set up your simulation, so 90% make their plane flights, and then 10% of the people who purchase a ticket, they just simply don't show up for whatever reason. Okay. So because of this, Southwest, they're trying to maximize their profits, and so they're going to overbook their flights. What that means is they're going to sell more tickets than they have space for on that particular flight. Okay. So the details are there's 10 first class seats available, but 12 tickets are sold. So they're overbooking by 2 passengers. Okay. Now these are first class tickets. So they're going to get a lot of revenue for those 2 additional first class tickets that are sold. But if you have to understand the context and sort of contextualize this. Like if you purchased a first class ticket, which is going to cost a lot of money, and you get to the airline, you get to the airport, you line up, you get there, and you find out that there's no seat for you when you paid, $1,000 or 2,000, whatever, however much. I don't even know how much first class tickets cost, but you're going to be extremely upset. And once Southwest loses a customer, that is like the worst thing that they can possibly do, because they're also going to lose that customer's friends and family. And, you know, any kind of business is based on building relationships and repeat business, right? So having a disgruntled customer is really a bad thing. Okay. So beginning on line 130 on the table of random digits, run a simulation of 3 different flights and explain to Southwest whether or not you recommend continuing this practice. So these are 3 different flights. So some of the errors, like some people didn't set up the simulation right. One of the common student errors was people set this up as a state plan do conclude, but in the do, they didn't show the simulation or the results of each trial. I had a couple students do 36, 36 things instead of 3 separate flights of 12. Okay, so there's just different things that occurred. So let me show you some of these student exemplars. And again, this is not an exhaustive list, and these are not necessarily perfect, but they're pretty close, okay, or they are perfect. So here the student sets it up as a state plan do conclude. You can read the state in the plan, okay, but basically you can choose any digit from 0 to 9. That's 10 digits, right? So you can choose any one of those digits as representing the person who doesn't come, who purchases a first class seat but doesn't show up. And then the other 9 digits you define as the people who purchased the first class seat, Southwest ticket, and they do show up. Okay. So in this case, this student used 0, which is very common. Okay. And then 1 through 9 are the first class passengers who do come. Okay. And then you explain how to do the simulation. Then you actually show the results of the simulation right here. So here's the first flight, and you summarize it. All seats are full, but 1 passenger does not have a seat. Okay, because 0 means somebody doesn't. So there's 1 0 here. So out of 12 tickets sold, this person bought a first class ticket but didn't show up. But 11 people showed up, but there's only 10 seats. So one first class passenger is going to be very upset. In the second flight, same thing. Another passenger is going to be very upset. And the third flight, luckily, 2 people bought first class tickets and just threw their money away. They couldn't make it for whatever reason. And so all 10 seats get filled. Okay. Now, your conclusion is you just have to base it on common sense. Do you think that on this simulation of just these 3 flights, if these 3 flights are representative of the entire system that Southwest is using to overbook flights, should they be continued? No, they should not, right? you would recommend that no, they need to stop this practice because you can't have a pissed off first class customer 67% of the time, 2/3 of the time. That is not a good practice. Your business is you're going to go out of business, right? So some students went beyond that in their conclusion and said, well, and these are the real like hardcore AP Econ students. They're like, yeah, to maximize their revenue, Southwest should continue this practice of overbooking, but they should only overbook by 1 seat instead of 2 seats per flight, right? And then in that case, this would be full, this would be full. Yeah, so makes sense. You'd have 1 empty seat, okay, but that's okay. Okay, here's another exemplar, and this student used, okay, again, this student chose 0, okay, which is fine. You don't have to choose it. You could actually use any of the digits. You don't have to use 0 or 9. You could use 7 or 3 or 4. It doesn't matter. You can choose anything, okay? So same thing, same conclusion, very good. Okay, very nice. Same kind of thing. Okay, I do not suggest they continue this practice. Okay, so that's pretty clear. Question 2, basketball player took 3 free throws, and what is the sample? When it says describe the sample space, so I think some people got thrown off by this word describe. That is a word that we often use in statistics but what it basically means is don't describe it, like don't explain what a sample space is, okay, which is how some students interpreted this problem and lost points. But describe the sample space means basically just list the sample space. Okay, now this question, technically, when you're describing a sample space of a basketball player who takes 3 free throws, it's supposed to look like this, okay? So the sample space, capital S, is supposed to look like this, okay? So define the 2 random variables. A is making, B is missing, and here are all the different values in the sample space. So you have make, miss, miss, etc., etc. So there's 8 of these possible outcomes, okay? So this is what your sample space is supposed to look like, okay? So this student decided to do it on all words, and again, 8 outcomes, that's fine. That's, it's not really the best way to do it in this kind of narrative style this way. Okay, this is the classic, capital S equals, and then set notation. Okay, but this gets full credit. Okay, here I went back and pasted a different one. This person split it up 552, 552, something like that. Here we go. This student did both narrative as well as kind of like a version of set notation. Okay, what else? And I guess that's all we have. Okay, so this is what it's supposed to look like. I mean, technically, a sample space really is supposed to look like this. And many of you got perfect, full credit, got it perfect. I went back and read, for those of you that had set notation and put 0, 1, 2, 3. Okay, originally I marked 1 point off for that because that shows, yeah, you can make 0 or you can make 1 or you can make 2, but it doesn't show the different combinations. Okay, so this is, just so you know, this is the correct answer. But for those of you that put in set notation 0, 1, 2, 3, I went back and there's quite a few of you. I think there was about 5 people out of 64 that did that. And so I thought, well, wait a second, this is a pattern. So I went back to the textbook and I can see why you put that, because when the textbook is describing what a sample space, it says, oh yeah, the sample space lists all the possible values. It doesn't say all the different outcomes. Okay, and then I think they talk about a coin, whether it's heads or tails, if you flip a coin 3 times, okay, and they put, they define like how many heads can come up, 0, 1, 2, or 3, something like that. So that's, you guys got a little confused. So I went back and gave you guys full credit if you put it in set notation and you put 0, 1, 2, 3. But technically, this is what your sample space is supposed to look like. Okay. Okay, so for these questions, these are going to take a little bit longer. So standard deck of cards, event A is the first card is a heart, and event B is the first card is a spade. Okay, so when you get a question like this, a lot of you guys kind of misinterpreted this question. Okay, and you're like, oh, okay, well, these are clearly independent events because, if the first card is a heart, then it has no bearing on the first card being a spade. But that is wrong. Okay, so these are not independent events because if the first card is a heart, then this probability goes to 0. Okay, the probability that the first card is a spade now goes to 0 if you already know that the first card is a heart, and vice versa. Okay, so these are not independent events. Okay, so let's look at some exemplars here. Question number 3. This was an exemplar for 4. Okay, I may not have pulled. I know that some people got perfect on 3, but let me just show you my answer for 3. So this is the way that I answered 3. I defined event A as first card is a heart, B as first card is a spade. Okay, and this is not very thorough. I should have said, A equals the first card is a heart. First card pulled is a heart. The first card, but this was just kind of for myself. And these are mutually exclusive because if the first card is a heart, it cannot also be a spade. So the probability of A intersect B it's 0. Okay, the probability of it. And then question B is describe it in set notation. So I don't, set notation, this is not even in AP stats, but going back to previous math classes, set notation is you're going to use the null set or the empty set. Now, a lot of you put inside your empty set, you put the null. And so technically that's wrong. Mathematically that's wrong, but I give you full credit because, again, that's not, set notation is not a question you're going to get on the AP exam. Okay, but if you put like the empty set, that's technically correct. Or if you put the null set, the 0 with the line through it, that's correct. But if you put the null set inside the empty set, technically that's incorrect, but I gave you credit. Okay. Are these mutually exclusive? Yes, and explain why. And are these independent? No, because the probability of A, and this is not even correct, right? Because I forgot that it's the first card. It's the first card is a heart and the first card is a spade. Okay, so this is not correct. So this should not be 13 out of 50. This should be 0. Okay, so if you pull if you pull a heart on the first card, okay, then the probability that you pull a heart, given that you pulled a spade, that is not 13 out of, that is 0. Okay, I forgot about the word first card. Okay. Okay, so question number 4. A lot of errors on this one. And this one was not easy. Okay, I don't know if we've done a lot of homework problems where you have a Venn diagram with 3 events happening. Okay, but this one, I'm going to show you my answer first because I know like what my flow of my thinking was. Then I'm going to show you, I think I only pulled a couple exemplars, but some of you got 100% on this. Many of you got very close to 100%, but you missed a key piece of information. So the data of the AP courses that DHS students take were analyzed. So here's all the data. So before you even look at this, the data of the AP courses that DHS students take were analyzed. So does this mean, does this sentence, are you inferring that, are you concluding that this is saying that every single student at DHS, yes, they do take an AP course? No. Okay. What is the population of interest? The population of interest is DHS students. Okay, so there are going to be some students that are DHS students that don't take any of these 3 AP courses. Okay, so that's your sample space. Okay, that's the thing that's outside of the 3 bubbles or the 3 circles. Okay, and that was a huge common student error. And, I'm sure that that's kind of my mistake, because I assumed you guys knew how to make Venn diagrams, but I think you guys either forgot, or I don't know what happened, but a lot of people, probably more than 10 students, maybe even 15 students, did not include the sample space. You got to put the box, and you have to put, what is that percentage or that probability that's outside the 3 circles, okay? Because the sample space has to add up to 1. Like, everything has to add up to 1, okay? So that's the first thing that people misinterpreted, or missed. And the first thing that people misinterpreted were some people were reading this as, oh yeah, everyone takes an AP course. No, okay. Or some people read this as, our population of interest is just AP students at DHS. No, our population of interest is all DHS students, okay, not just the AP students, okay. So the first thing I did was I took all this data, and because all these questions ask about probability, okay? Technically, and I know this is a technicality, but this is something that, coming out of my class, you need to know the difference, okay? When we're talking about a probability, we're talking about a number between 0 and 1. And I know the authors sometimes talk about probabilities in terms of percentages, but that is wrong, okay? Percentages are what the book and the authors and statisticians refer to as proportions, okay? Proportions. And again, that's different than in other math classes where a proportion is just 2 ratios that are equal to each other. That's not what we're talking about. When we talk about proportions, we're really talking about percentages, okay, or part of a whole. If we're talking about probabilities, we're talking about a number between 0 and 1, a positive number, okay? So between 0 and 1, okay, inclusive. So the first thing I did was I just wrote down all these numbers and figured out, well, what are they? Well, actually, before I did that, let me just show you, okay? So first thing is we need to define our 3 random variables, C, B, and S. C for chem, B for bio, S for stats. Some of you used A, B, C, some used X, Y, Z. It doesn't matter. You just have to define it somewhere, okay? Then I just put down all the information, okay? These are just the given information from these, okay? So 0.22, 0.07, 0.06, okay, 0.22, 0.07, 0.0. And here's the thing, you have to be able to read what these are. Are these intersections, or are they conditional probabilities, okay? And then when we get down here to probability of S, probability of C, and probability of B, okay, 36% take AP Stats, 31% take AP Chem, 33% take AP Bio, okay? That is 36% of this population, okay? And that is the entire bubble. That was a huge common student error, which really kind of bugged me, okay? So if B is my bio bubble, okay, and if I know that 33% of Dublin High School students take AP Bio, this entire bubble has to add up to 0.33. That's how you find out what these 3 intersections are, okay? So this portion of the bubble is not 0.33. This portion of the bubble is all 4 of these numbers have to add up to 0.33, okay? Same thing with the chem bubble. All 4 of these numbers have to add up to 0.31. Same thing with the stats bubble. All 4 of these numbers have to add up to 0.36. And by the way, stats has the big, yay, go stats. Anyways, and then it's very simple to figure out, well, what is the sample space? So what are these guys? These are the students that they might take an AP course, but they don't take AP Stats, and they don't take AP Bio, and they don't take AP Chem, okay? So I redrew this because these numbers were getting real small and squinchy. So I kind of redrew this. I just made the Venn diagram bigger. So here's stats, here's bio, here's chem, and then here's the students who maybe take an AP course but don't take. Okay, this is the intersection of S complement, intersect B complement, intersect C complement. Okay, the probability of that intersection. And that's that right here. Okay, probability of S complement, intersect B complement, intersect C complement equals 0.16. 0.16. How did I get that? I added all of these up, okay, including these, okay, and 1 minus this entire thing. Okay, so after you guys figured out all these, you have to figure out these little intersections. And many of you, common student error, a lot of people misinterpreted these, right? So 0.07 is S intersect B. So let's take a look at this. So S intersect B. So 7% takes stats and bio. They might also, some of these might also be taking chem. Okay, so that 7% is the football intersection between the S and the B. So this entire football is 7%. But some of that 7% also takes, in addition to S and B, also takes C. So that's where you get the 0.02. Okay, and that 0.02 was given to you. So that's how you figure out that this has to be 0.05 because the whole football is 7%. This tiny piece, these overachievers are 2%. So this kind of weird shaped, I don't know, triangular, I don't know what you'd call this part of the football is 5%. Okay, so you got to figure out what these intersections are and you have to interpret these properly. Okay, so this 2% is this triangular kind of region. Okay, super overachievers, they take all three. Okay, it's S intersect B intersect C. But then this 7% is S intersect B. This 5% is S intersect B intersect not C or C complement. Okay, all right. So that was the biggest common student error. Once you figure that out, and once you have these intersections correct, boom, the rest is super easy, right? Because then you're just looking up values or adding values, right? Okay, so probability of randomly selected is not taking any of these. We figured that out. 0.16. Find the probability of the randomly selected student takes AP Stats or AP Chem. AP Stats or AP Chem. So that's all of AP Stats plus all of AP Chem. Subtract the entire intersection of S intersect C. So that's 6%. Okay, so that is 0.36 plus 0.31, the whole circle, minus the whole football, the whole intersection. Okay, so that gives you your 0.61. Okay, so next, find the probability of the random student takes AP Bio. Given that, so now you got a conditional. So I got B line or given that stats. Okay, so it's out of the AP Stats students who also takes AP Bio, right? So out of the AP Stats students, there's 0.36 of them who also takes AP Bio. Well, that's 7%. So 7% out of 36% gives you 0.1944. Okay, boom. So let's look at some student exemplars. So here's one. Ignore this part 3, but look at B. So the student defined AP Chem as A, AP Bio as B, AP Stats as C. So here's Chem, here's Bio, here's Stats. Okay, the student, she figured out all the intersections properly. Okay, figured out all the work, set up the probability, shows all the work, plugs in, substitutes the values, does the arithmetic. Okay, and the answer is in probability notation. Okay, it's in probability notation. That's perfect because this asks find the probability that a randomly selected student does not take any of the, so it's in probability notation. So whoops, so it's 0.61. Okay, 0.1944. Okay, and there's a couple others, but I think I just pasted that one. All right, so 5, certain AP Stats class has 25% of blah, 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 blah. So this one, most of you had no problem. The overwhelming majority of you did great on the tree diagram. And remember with tree diagrams, this is my work. Okay, the first decision is what class you're in, sophomore, junior, senior. Notice there's no freshman in AP stats. Okay, we don't allow that. Okay, and then from each branch of these, you have either yes or no, yes or no, yes or no. Okay, and so these are the conditionals. This is yes given sophomore, no given sophomore, yes given junior, no given junior. And then this is your intersections. So this is sophomore and yes equals, you just multiply 0.8 times 0.25, multiply the branches, etc., etc. I always like to add them up, make sure they add up to 1. That's an important thing. Okay, now here's the deal. Look at the question stem. The question stem says what proportion, not what is the probability. It says what proportion. So now you need to answer like this. Okay, here's my probability statement. That is not answering the question though. 0.315 according to AP stats is not really a proportion, right? So you want to answer in a sentence. Okay, so part C, what proportion are not taking the AP stats at the end of the year? You just add up all the no's. Add up all the no's. Okay, you just add up all the no's. 0.05, 0.06, there's 3 no's, right? So here's the no's, 0.05, here's the no's, here's a no. Okay, you just add those up. So about 14.5% of these students are not taking the AP stats at the end of the year. Okay, then finally, we have a conditional. What proportion of students are taking the AP stats at the end of the year? Given that, that's your condition, they are seniors. Okay, so probability of yes given senior. Probability of yes given senior is equal to 0.85. Okay, that's right here. That's your conditional. These are your conditionals, right? This is the yes given senior. That's the no given senior, right? So no math involved there, just answer properly. Okay, here's some exemplars. Okay, very nice. I love this one because look at what this student did. This student labeled everything perfectly and even shows, this student was more thorough than I was, even shows that here's all your conditionals and here's all your intersections. I was a little bit lazy. I didn't show all that. This is better than mine. Okay. There's all the work. Okay, and the student goes back and answers appropriately. 14.5% of the class is not taking the AP exam. 85% of seniors. So this student, first of all, just wrote probabilities, and then she goes, wait a second. She went back and read the question, says, hey, I have to answer the question. 31.5% of the class is blah, 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 blah. Okay, well done. Here's another one laid out a little bit differently, okay, vertically, which is perfectly fine, okay. I like the highlighting of the answers. That just makes it super easy for me to read the answers. Now, technically, these are not really correct because you need to answer in a sentence and use proportions, but this is beautiful, beautiful, very, very neat work, very easy to read, very easy to follow. Here again, you have a really nice table or tree diagram. Here's the probabilities. Okay, again, you need to write the answers in proportions. Okay, all right. Question 6, random sample of college undergrads and grad students are asked if they prefer desktops or laptops. Okay, so a lot of people did this with a two-way table, which I thought was more brilliant than the way I did it. I thought about, do I want to do a tree diagram? Do I want to do a Venn diagram? What do I want to do? Guess what I did? I just went ahead and made a Venn diagram. Okay, normally I like to do tree diagrams, but I went ahead and did a Venn diagram. Okay. All right. So I define D as desktop. So DC or D complement or not D would be laptop. Okay, and then U would be undergrad, and then not U would be grad. Okay, and then these are just my givens. Okay, so from my givens, you can just figure out basically everything, right? You can figure out all this different stuff. Okay, and the big deal here is you really have to remember this right here, right? This right here. The probability of this, okay, this given that, this conditional probability is equal to the intersection over the probability of the condition, okay, of this in the numerator. Okay, so remember I kept emphasizing when I was lecturing, hey, memorize this formula and all 3 iterations of this formula, right? So super important. If you haven't memorized that, you need to memorize it now, okay? So yeah, this is just, there's my work. You can look at it, screenshot it, figure it out. I think, visualizing it helps a lot. And then writing down correctly or interpreting all the different given information helps. And then knowing the this formula. Okay, so let's look at some student exemplars. I really liked this because this one blew me away. I was like, this student was like, let's make a two-way table. A lot of you made two-way tables. This was brilliant because when I saw this, I was like, oh, this is better than a Venn diagram. It's easier to read. Right? You just have to know that your intersections are inside, and then your conditionals are like, depending on what you're holding constant, if you're holding a column constant, then it's like this over that, or if you're holding a row constant, or if you're holding a column constant, then it might be like this over that. Okay, but that's how you figure out your conditionals. Okay, so given that it's grad student, so now we're only talking about grad students, so your numerator is obviously 0.6. Okay, who likes a desktop given a grad or out of the grads? So, well, it's 0.4 out of 0.6. So 2/3 of graduate students like desktops. Okay. This student also did a two-way table. I like the two-way tables. I think it just makes it very clear. And same answers. There's all the work. This student also did a two-way table. Again, two-way tables were a very popular option. Okay. But I went ahead and went that way with it. Okay, guys, that's all we have.